In this video we're going to look at sample mean and z-scores. So we learned how to get z-scores of population proportions. Okay, this is slightly different. If you look at the last video we were looking at sample means and the central limit theorem. Well, this is to do with that. So just explain the question first. A random sample of 250 is taken from a population having a mean of 30 and a standard deviation of 5. Find the probability that the sample mean is greater than 30.5. So basically there's a population of people or of whatever, and it has a mean of 30, so that's the actual mean of the population. Also the actual population has a standard deviation of 5. We take a sample of 250 from that population. We're looking for what's the probability that our mean is greater than 30.5. Okay, so the actual mean is 30, but we take a sample. What's the probability that our mean, the mean of our 250, is greater than 30.5? Okay. To do that, we have a formula. It looks like the normal z-score formula that we're used to with population proportion. Let's say if there's a slight difference and the denominator. If you look at this, this is basically the standard error or the standard deviation of a population mean. Okay, so it's standard deviation over n. Okay, so instead of just having root n, we have standard deviation over root n. So that's the only difference to that formula when we're talking about a sample mean. So what we do, we put in our mean, we put in the actual mean, we put it over the error, and we get 1.581. We're looking for the probability that the mean is more than that. So it's to the right. Okay, so it's this way. So what do we do? Well, we look at our tables and we see that the score, the probability of getting less than 1.581 standard deviation is this. So that would be the chances of getting less than it. We take it away from 1, we get this 0.0591. If we change that into a percentage, it would be 5.91%. Okay, so we have 5.91% of our mean being greater than 30.5. Okay, that's that, guys. Thanks.